In this video, we're going to work out the arc length of a cycloid. So this is our cycloid here, and let me illustrate it. So this is our cycloid here, and we're going to work out the arc length from 0 to 2 pi right here. So we're going to work out the arc length from here to here. And we've seen this before. The position vector is given by this, and we've seen this, so I'm expecting you to know this by now. So the arc length, the formula for the arc length is given by this, which we've already seen as well. So you want to differentiate the x with respect to t. So looking at the x component, differentiate it, that will then give you this thing here, and then we need to square it. And then looking at this, we need to differentiate the y component. That will then give us this thing here, and then we've got to square it, and then integrate the square root of the whole thing with respect to t from 0 to 2 pi. So the arc length is given by this. Okay. So now multiply this out. If you square this, it will then give you this whole thing here. And this thing becomes this, and then you can combine these two to give you 1. So this block here will be 1, and then you get this 1 combined with this, that will then give you a 2. So this whole thing here will then become this, and then factor out the 2, that will then give us this, and then let me think. And then this block here, well, you must know this by now. We've seen this many times. You have to know this by heart. Well, if you look at what's going on here, this thing here actually leads to this, and then you can times both sides by 2. So now you've got 1 minus cos t. So you can actually put this into this block here. You can actually, think about it from here. That this thing here would lead you to here, and then times both sides by 2. So that will then give you this, and then you can see that this block here is exactly the same as this block. So you would put this into here. That will then give you this thing here. But let me explain this bit here, how you can jump from here to here. So I'm expecting you to know this by now. If you sine the angle, let's say you've got an angle like this. Let's say this angle here is x. Or well, if the formula, this formula here will work even if the angle here is y. So it works for all angles. This side will always equal this side. Suppose you have a weird angle like this one here, z. Well, this angle here will still work. This side will always be the same as this side here. So now consider going back to our angle x here. If you have half the angle, it should still work. This side should be the same as this side. So if you put this half, so we are talking about this angle here, which happens to be half of x. If we put this into here, that will then give us this thing here. But then when you put this into here, you times 2 here. That will then give you this. So the point here is that if you have an angle of x, it will still work if you have half the angle. If you use this angle here, if you want, you can call it a different name and put it in here. It will still, this same angle will still work. Well, anyway, from here, that will then take you to here, and then times blah blah blah, and then we are now here. So now let me think. So you've got 2 times 2, and then you've got to square root it. You can actually take it out here. That will then give you this. So now you've got sine squared and then square root it. Well, when you square something and then square root it, it's really you looking at the absolute value of this thing here. So from here, this is the same as the absolute value here. So if you look at this here, hang on, let me think. If you look at sine of x, because we are looking at this thing here, sine of x, one period is So well, t, we are integrating t from 0 to 2 pi. If well, t is from 0 to 2 pi, so divide everything by 2. Well, the point here is that this quantity here will always be trapped between 0 and pi. So this thing here is always trapped between 0 and pi, meaning that sign of this quantity will always be positive anyway. So we can forget about the absolute sign and just jump from here to here, because this quantity here will always be positive. Okay, so from here, that will then take us to here. So now it's just a matter of integrating this. So to integrate this, you're looking for something in such a way that when you differentiate it, it will give you this. So make this to be your initial guess, cos t over 2. I'm going to need a minus. I'm going to make this to be my initial guess. So when you differentiate this, it will be sine t over 2, but then you've got to times the derivative or the bubble itself, which will be a half times a half. But you want to negate this half, so you would go back here and stick a 2 in here. So now when you differentiate it, it will give you this without the half. The point here is that integrate this, it will give you this thing here. So now we can put this into here. So that will then be, well, if you put 2 pi into here, 2 pi divided by 2, this thing here will then become pi. And then cos of pi, this is 2 pi, cos of pi is negative 1. So this block here will be negative 1 times negative 2, that will give you positive 2. This 2 here is this 2 here. So that will then give us positive 2, and then we've got to take away, and then put 0 into here. 0 divided by 2 is 0. This block here will become 1. 1 times negative 2 will be negative 2. The whole thing here will then become 8. So the arc length of the cycloid, is 8. Okay.